Hello. So this is equilibrium problem. So determine the magnitude P, the force which the man exert to the handle of the high pressure washer in order to cause a loss of contact at the front support B. So at the support B, you have here no contact, meaning there's no force in this support B. Note that the operator prevents the movement of the wheel with his foot. So there's the foot. The 60 kg machine has its mass center at point G. Treat the problem as two-dimensional. Okay, so the given, you have the mass, that is 60 kg. Then the normal force at B, so you have zero normal force here because there's no contact. Okay, then we are required to determine the force P. So the next that we're going to do after the given and required, we will draw the free body diagram. Okay, so we will just draw a simple lines. Okay, here you have 3.1. So you have 3.1. So let's say here. Okay, that's 3.1. Then the other one is from here to there, that is 4.35. So I will just estimate it here, there. Then you have from this point, this is 0.0, although the handle, it is offset here, but as you notice, the dimension is at 0.0 and at point A. So it means from here, if you draw this one, that is 800 mm. So we will just draw a 30 degrees. So 30 degrees. Okay, so it's there. So we'll just erase this one. Then you have 80. So it's almost in the top. So 80. Then take note that the force is perpendicular to the handle. So that is there. Okay. So you have here the free body. This is the free body diagram. Then we will indicate the forces later. There. Now, what are the forces that is connected to this frame or to that system? So you have first, that is the force P. It is here. Okay. Then the next one. Now, if you look at the foot, don't worry about the foot because the wheel, it's not included, but the hinge in the wheel at 0.0, it's included, and it could be illustrated by this force O, Y, and the other one is O, X. Okay. Then you have at this point, that is at G, you have a weight that is, in this case, 60 kilogram. 60 kilogram. And you should have, since meron dapat dito normal force, kaya lang ito ay 0 na kasi walang contact. So yan yung iyong free body diagram. Okay? So FBD. Free body diagram. So diyan ka mag-uumpisa. Kapag may na-miss kang isa diyan, mali na yung sagot mo. Okay? So hahanapin natin itong force P. Okay? So how to do that? So this is in equilibrium, meaning there's no acceleration involved. or it's not moving, it's not rotating. So for equilibrium, you have the equation for equilibrium. You have summation forces x and y equals 0, and summation moment xyz, that's 3-dimensional, that is 0, but in this case this is 2-dimensional, so it's just like that. Okay, now we're looking for this one, so we can start. If we start with force, summation forces, this is unknown and this is unknown, so it's better to start with summation moment. Then if I have a moment here, this is unknown, so I will magmo-moment ako dito sa point na ma-eliminate yung OX and OY. So dito sa O ako magmo-moment. Summation moment at O equals 0. Okay? Tapos, syempre, mayroon siyang dimension dito. The dimension is 310 mm. And this one is 125. And of course, ito ay nasa 800 mm. Okay? So, pag nag-moment ako dito, syempre, wala yon 0. So, hindi ko na-include kasi wala ng moment. Dito sa 600, you have 60 pala. The force is 60 multiplied by 9.8 para maging Newton. So, you have 60, okay, times 9.8 para maging Newton. Then, times the distance. Okay, this is the force and the distance is 125. Okay, and that is counterclockwise. In our notation, counterclockwise is positive. Then, what's next? This one. Okay, now take note that this is perpendicular, so obviously the force P, so you have P multiplied by the perpendicular distance, that is 800. Now, is that positive or negative? Since it is, the rotation is clockwise, this is negative, then wala nang ibang force kaya 0. So, P now, it's equivalent to 91.9688 Newton. So, that is the force P. Okay? Now, if you want to determine the forces OY and OX, so you just make a summation forces Y equals 0. Okay? But, you need to, what are the forces? That is Y, so you have the 60. So, negative 60 times 9.8. Okay, so no distance anymore because this is force. Then you have positive OY. Okay, so this is 0. You have this one, ito yon. OY, OX, nasa X naman. Then, of course, you must have the component of PX and you have PY. Okay, so in this case, you now have plus, no, it should be minus PY equals 0. So this can be determined because you have the P there. All you have to do is determine the angle here. Okay? So yan. Para makuha naman yung OX, so negative 60, sorry. Walang X yan. So OX, negative OX, then you have plus PX equals 0. So, meron ka nito, masosolve mo yan, then you determine the OX. So, ganun lang siya. Now, paano naman kapag, syempre, ito, hindi perpendicular. Halimbawa, nakaganito. Ayan. Halimbawa, ganyan. Force P. Tapos may angle ka dito na ganyan, theta. So, ang gagawin mo, kukunin mo yung hindi na 800 yung perpendicular distance mo, kundi i-plot mo ganito. Then, dapat perpendicular yan. So, yan. Hanapin mo tong distance na to. Kaya lang, medyo mahirap yan. Pero pwede. Ang pinakamadaling gawin ay gawin mong component yung bagong P. So, bagong P na tayo ha. So, sa bagong P, ang component niya ay so, yan. So, ito yung bagong component dyan. You have PY and you have PX. So, yan. Pag nakuha mo yung bagong PI saka PX, pero hindi yung value, so, depende dito. So, yan. So, PX, in this case na, so, P, in that case, that is cosine theta, and PY, it's P sine theta. Ngayon, ano naman yung distance? Siyempre, ito, magkakaroon ka na ng yung PY, yung distance sa perpendicular distance niya, ito na. Yan. Hanapin mo ulit yan, based dito sa 800. Saka dito sa angle na to. Yan. Tapos yung isa naman, yung distance niya ay ito naman. Okay? So, you can solve x, w of x, and y. Then, mag-summation forces, summation moment ka. Summation moment ka muna at point O. Makukuha mo na yung bagong P saka OX and OY. Okay.